as well.
I did start. Sean, I did start the recording.
Okay, cool.
Okay.
Thank you.
Okay. Thank you.
Okay. Hi, everyone. Let me share the screen and then we can start the session. Okay. So just if you are new, I see there's one guest. So if you are new to the group and it's your first time, just jot down my cell phone number as well to join our.
Noise. I don't know if it's only me. Can somebody else just give a thumbs up if it's you as well? If they can hear it, is it only my connection?
Okay, I'll ask if it's only me. Can you guys hear me? Is it only Claudine's one that is making weird noises, or can you guys hear me clearly?
I can hear you clearly.
Okay, Claudine, it's maybe then something with your connection that is weird, but at least can you hear me? Okay, so Patricia, it was on your side as well, but now it's fine. Okay, cool. Okay, awesome. Okay, so just if you are new, we have a WhatsApp group and you can send me during the session, after the session, WhatsApp, and I'll add you to the group. And I know we have been sharing a bit the last week or so, and we will be sharing more. So more tips, more information, more things that can assist you in the exams. And I think you guys are now finished with your with the assignments, but basically then for exam preparation. And also, if there are things being shared that I don't have access to, you can also share that on a WhatsApp group for me, please. So things like if I give you a mock exam or anything like that, please share that on the group that I can look at that as well. Your guys would have now completed assignment 3, and basically assignment 3 is going to be very similar to your exam paper. So I think if you're well prepared with assignment 3, then you will be okay for the exam. Okay, today I want to let us focus on differentiation and the start of that, and nearly to start explaining it. What worked very nicely last semester was, so I will take you through nearly the info in the study guide, but nearly explaining that to you. So, and we are still a small group today, so please interrupt me when I need to explain something again. I think differentiation is very important to understand, and integration is nearly the opposite of differentiation. So if you have an idea how to do differentiation, then integration becomes a bit more easier as well. So as usual, I will take you through some of the theory. Nowadays with the exam that is nearly online based, there will be less theory. So because I know something like that was in a previous exam. So let me quickly, I know in a previous exam, there was something like that was given. So they said which one of the following 5 or 4 formulas represent the slope. But now it's merely very difficult to ask that same question if you can just look at it in your textbook. So they need to think about it a bit differently of how they're going to ask the questions. And that's why what we have seen in semester 1 was that it was nearly all practical exams or practical questions, much less of any theoretical questions. So I think that is important. So let's go on to the rest of this. So what basically they're telling us, and I think that is also nearly when we differentiate, we nearly work out what is that slope or that line touching at a certain point. So if it is, and I'm just going to make up now a formula. So if we have that as the formula, so it is to the power of 2, so it is for, and how do you pronounce it, hyperbole or hyperbole or whatever, but basically it is that slope. So when you differentiate that, you will get something that just have a x, and then we know that x is a straight line. So that's why when you differentiate a quadratic, is it a quadratic? Let me just make sure, to the power of 2. So if you differentiate that, you will get the slope or the line going through that point. So what integration then does, so let me just take you in 2 or 3 weeks when we get there, it's basically from that point you work backwards to get that one. So differentiation is really breaking it up into the first part, and then integration is taking it back. So and a simple example is nearly when we need to differentiate, always remember what we're doing. So we basically, when we differentiate, we say whatever was there goes in front, and then whatever is there for the next one, we nearly say -1. So if we differentiate x to the power of 2, it will become 2. At that point, you will say 2 minus 1, but remember 2 minus 1 is equal to 1. So to write something as 2x, or to write it as 2x to the power of 1, is exactly the same. And I think that is also important at a later stage when you need to go back to integration, that you nearly remember that if there is nothing there, there's actually a 1. Just so that when you integrate, you need to know what happens then. So differentiation is basically, that is the process. Obviously, there are rules. So if dependent on how the formula look like, there will be different rules. And I think that is also important, is that you will get a few rules when we do differentiation. I will share that later on the group as well, because we basically have a few rules that we look at, and I have written a few comments on that, so I will share it with you. So I will later on tonight just take a few pics of that and share it. Okay, so up until this point, you understand what differentiation will do. So I'm asking. And if yes, happy, we can go on, because I think it is important that we get to some of the rules of it, and when there's log rules with that and things like that. So you guys happy until now?
Yes, thank you.
Okay, cool. Okay, so yes, Seva.
So, can you hear me?
Yes, I can.
Okay. So what you are saying is that, say we get x to the power of 3, then you put the 3 in front of the x, and then your power of becomes 2.
Yes. So
Okay.
that will be basically 3 minus 1, which will give you the 2. So
Okay.
yes.
Thank you.
Perfect. So for the simple one, that is exactly what you do. Perfect. Okay. So what we also do see is, and I think that is nearly part of the power rule as well. So let's exactly what you now said, Eva. If it was like this one, very similar to nearly x to the power of 3, so that will just become 5x with 5 minus 1 will then give you 5x to the power of 4. Okay, so that is nearly in a sense very simple to just say that, and it's nearly to, I think that is, I don't know if there was anything like that in your assignments. To be honest, that was just that straightforward. I think it was more combination nearly of a few things. So that is nearly the straightforward one. I just want to see. So let's go into. Okay, so let's take this one as an example as well. So I'm just going to move. Let's move that a bit. Let's take that out. Okay, so I'm basically looking at that one. So also just again to show if there is something already in front of it, it's not that you just put the 3 there. So what will happen is it is 10 times 3. And then it will be x 3 minus 1. So whatever was in front of there or at the top, you still need to multiply it with a 10. So that your answer will be 30 x to the power of 2. Okay, so that is just showing that if there is something in front, that is what you need to do. And let's look at that one, but let's do a different one. If it was 10x or minus 10x to the power of 3, and we needed to differentiate, exactly the same process. So it will be minus 30x to the power of 2. Daryl, let me quickly, I will load it onto, let me quickly just see if it is, I shared it in this link. So if you go back, oh no, that is not, yeah. See if you can access in the chat the link or the presentation. If you can't, I will just share it on the WhatsApp group tonight as well. But see, that is supposed to be the presentation that I loaded up early in the week. So please see if you can access it. If not, I will send it to you, and I'll also see if I can load it somewhere else that you guys can have access to it. So just see if you can download it out of the chat. I don't know if I've. Okay, cool. Okay, so basically with this one, the same principle applied. So whatever was there, we need to work with, and the same if there was so if it was a half, and let's just make it 4, then it would have been a half times 4 x to the power of 3, and that would then have been 2 x to the power of 3. Okay, so whatever is in front, if it's a negative or not, we need to multiply that with what is the to the power. Okay, so that is just explaining a few other options. I think we will now go into, okay, we don't have it yet as a negative, so we'll get to that as well. So again, this nearly shows the same principle. I'm not really going to go in there. I want to see if there's a nice one that nearly has a lot of things in it. Okay, so we need to differentiate that. Okay, so yes, the answer is here, but I nearly want to go straight to, so basically x to the power of 4, it becomes 4x, and then it's 4 minus 1, which gives you the 3, plus we bring the 3 to the front, so 2 times 3 gives you 6, x 3 minus 1 gives you 2, so it's to the power of 2. Okay, so minus, so I automatically put the minus down so that I don't forget it. 2 times 5 is 10. There is a minus, so it's minus 10. X 2 minus 1 is 1, so you can write it as 1 or you can leave it out. Just when you see it in the exam, they normally don't write the 1 with it. So you just need to remember, if there's not anything with it, it's not that it's a 0, it is just a 1. So that it's not. Then this one is the interesting one. So remember, there is a 1. So 1 minus 1 gives us 0. So from maths, x to the power of 0 is equal to 1. So that is just a basic rule that we need to know, is that x to the power of 0 equals to 1. So basically here we have 3 times 1. So that, when I differentiate that, will be 3 times 1. Then you will see that at the 100 there is no x. So when we differentiate a constant, the constant is equal to 0. So the constant will basically fall away. Okay, and then that is our final answer. The only thing that I would probably change is that, and that one I would just make that it is 3 times 1 that they have given me 3, and you will see it is the same that we've got there. Okay, let's do a quick check-in if everyone is fine with that. Okay. Okay, happiness. Let's go on to the next one. Yes, no. The one that's uploaded will be the one before the workings. I will post the one with the workings afterwards as well. So no problem. I'll post the one with all the scribblings on as well. Okay, so now there's, if you look at some of these ones, and it is in your study guide as well. So the first one is a basic one that we nearly just covered. So that is straightforward. So it is 8 times 10, which gives you 80. And then the x is 8 minus 1, which gives you 7. Okay, so you will see, so that first one, very straightforward. It is how it's supposed to be. When there's something as a fraction, what I would normally do first, and what they also recommend, is that you make it a non-fraction. So if we have 1 over x, I'll just give you a few examples. If we have 1 over x, that is basically x to the power of minus 1. If we have 1 over x squared, that is equal to x to the power of minus 2. So basically, whatever is connected to the x under the line, when you bring it to the top, it will change signage. Nah, yeah, like as Neem says, never. Yeah, no. So you will never in the exam get a question like example 1. It's no. So, unfortunately, so you will never. You might get something like this, but then in this one there would have been probably something like that in, so that it's something different than just the straightforward one. But question of example 1, no, you won't get something as simple as that. Unfortunately not. Okay, so just something else, and this is more if I want to catch you out. So if I write something like this, so if I write something like that, and I don't want to link it to that, so if you, like I said, if you want to, I would always want everything to be on top so that there's not a fraction. You can change that as well. Just remember the signage was minus 2, so if you bring it to the top, it will change the sign, so it will become a positive 2. So just if I want to be nasty and do something like that. Okay, so we've now changed it to that. So basically now we need to integrate that. So if we now integrate that, again, that goes to the front. So it's minus 2. Remember, it is minus 2 minus 1. So minus 2 minus 1 is minus 3. So we sit with minus 2 x to the power of minus 3. And now you can see, again, dependent on how they want to ask it in the exam, that can be written as minus 2 over x to the power of 3. It can be written as minus 2 okay, so it can be written in a few different ways, and again it can be any one of those, so it is nearly to assess what your answer is and then to see what you need to get to. If it was not a multiple choice but a written exam, any one of those two will be right. But because it's a multiple choice, you nearly need to look for which one is in the choice of options. Okay, so option 3 is nearly the same as option 1 with something in between, so I'm not going to do that. I rather want to look at the question 4. So here we work with the function fx is equal to x minus 4 times 1 over x. So that automatically I will probably want to change. And 8 times 2 over x to the power of 2. So that I also would want to change. So how I would then rewrite that is the x is as is. Remember that minus 4 is, it stays there, or sorry, not the minus 4, the minus. We'll see now what we need to do there. So 4 times 1 gives you 4. So x we want to take to the top, so it's x minus 1. So the next one, it's 8, or it's a plus. Before we write the 8, let's see what we want to. So it's 8 times 2, so 8 times 2 is 16. The x to the power of 2 I want to bring to the top, so because it's positive, below the line, above the line, it becomes negative. And then from there on, it is, remember, x was 1, so 1 minus 1 gives you 0. So x to the power of 0 is equal to 1. So we just keep that one there. So the next one, minus 4 times minus 1. So minus 4 times minus 1 gives you positive 4. It is x minus 1 minus 1. So we'll get to that one now. Then negative 2 times 16 is negative 32. And then it's x minus 2 minus 1. Okay, so let's work with that one. So it is plus 4. X minus 1 minus 1 is minus 2. Minus 32. And x minus 2 minus 1 is minus 3. And then, like they did, now you can put it back into the positive to say it is 4 over x squared, and it is minus 52 over x to the power of 3. Again, I would add this, so I won't go from that stage straight to that one. So when I work it out, I will still include that part, because again, in the exam, they can have that or that as an option. So instead of nearly skipping it, now at least I know that those are the two options, and if it is similar to that, then I know which one to pick. Okay, so something like a question 4 is really possible in the exam, because that tests if you can do the normal differentiation with the negative. So that can be one that they can ask you in the exam. Okay, do you quickly want to ask a question, or can we go to the next one? Okay, so let's go. Okay, Candice, to quickly. Oh, don't worry to write anything down or anything like that. I will share this. I will share this. Okay, cool. So I will also share it on the WhatsApp group tonight. So so no worries. Okay, cool. Let's go to the next one. Okay, so when you look at question 5, it's like it looked very intimidating. But the one thing that we nearly need to remember with question 5 is that at the bottom of the line, there's only one variable nearly. So it's actually much simpler than it looked if we just write it out a bit differently. So how I normally look at it, if there's only one, so you have that is one of the terms, and that is one of the terms. So 5x over x is one of the terms, and one of the other terms is 2 over x. Okay, and now we can work with that, because now that again is something that we have seen before. With this one, before I even integrate, I would make that simpler. So we know 5x divided by x is 5. With that one, now you can see we need to change it up a bit. So again, I don't like to work with something that is below the line. So I will change it, but then it becomes 2x and to the power of 1, but negative 1. Okay, and then if we differentiate, when we differentiate a constant, that becomes 0. And then when we differentiate that, we need to remember the minus goes there, so it will become minus 1 times 2, which is minus 2x, and then it's minus 1, which gives you minus 2, and then we can write that again as minus 2 over x square as well. And as they write it, you can do it that way as well. So again, there's a few options nearly how to write it in the end. But again, when there is only one variable that you divide with, split it up, and then you can follow the same process that you have been doing with the others. Okay, we've done 6 nearly, so I want to get to something like this. So let's quickly see. That one is again very similar. So let's let's do 8. And let me explain 8 a bit. So and now it's nearly to say there's a few things that again from maths that we nearly need to know. So the square root of x is the same as x to the power of a half. If you have that, it is x to the power of 1 over 3. Okay, so just to show a few other options as well. So the first thing that we need to do with this one is, okay, so let's rewrite it as that. So it is 1 over x to the power of a half. So just, I think we've missed a step in the book. They've just missed a step so that you, and then because it's below the line, we need to take it to the top. That is how they got the x to the power of minus half. Okay, so then we are sitting with the same. I just wanted to show you nearly the step how they got from there to there, because it can be confusing if you just look at it from that point of view. Okay, so now it's actually very similar to all the things that you have done. So that goes to the front. So it is minus a half. The x minus a half stays there, minus 1. So the minus half is there. So minus a half minus 1 is minus 1.5. So you can write it as minus 1.5. The minus 1.5 can also be written as 3 over 2. So there's again a few ways how we can write that. And then obviously when we see that, it can also be written as and I should have done it in, so it could have been written as that as well, that part. We can have a minus a half in front of it. So now you can see if we have that in front of it, the 2 can actually go below. So we can, from that point, actually have the 1 at the top, and below we can have and then the next step, if we want to get to that, so here you've seen that in a sense there's actually a 2. Again, because of all the maths, they don't show that 2 because it's nearly that is how it's written. So that 2 reflects the 2 that is underneath the line. So there's a 2 underneath the line, so we can actually write that as that, and then your 3 just stays there. Okay, so that could have been now rewritten again. And that for me is, yes, it is nearly what I would look at the answers first. And then I would say, okay, how far down that rabbit hole I nearly need to go. Because again, it doesn't help me if I go all this way, but that was actually the solution, that was one of the options. So I would nearly look at my answer first to say, oh, hell, I need to, if I look at that, that is the answer. Okay, I nearly need to do the whole process. If it is with nearly something to a power of a negative, then I know it's probably after step 1 or 2 that I can actually stop. So I would nearly look at your answers and then say, okay, where do I need to stop with it? Because like you said, it is a rabbit hole. So you nearly can have 3, 4, 5 different answers, or not different answers, different ways of writing the answer. And it can be, and nearly like Tasneem said, it will never be as easy. It can be even that, and I nearly want to take a deep sigh here and say, I hope it's not, but it can be that one of your options is, say, I just want to see now if I'm writing it. So one of, okay, wait, let me just, so one of your options can be that. One of your options could have been that, but there's maybe a negative in front. One of your options could have been that, but that maybe was a positive. So it could be also that way during the stage as you go through it, there is an option that you nearly think, oh, I am at this stage. Oh, maybe I made just a signage problem and that should be it. So it can be, unfortunately, it can be something like that as well, which I hope it's not. But I have seen 1 or 2 that they do give you nearly the same answer, just a bit differently. And I will check in the exam papers. I think I've got a lot of them to see if there was anything like that. So, Colleen, that is unfortunately with this subject, it is you nearly don't know when to stop, and that is why it's nearly let the answers nearly guide you into at what level you need to go. Okay, before we take on the next difficult one, any other questions thus far, or can we try to go into this one? And this is nearly something that I think also might be relevant in the exam. Okay, so let's take on this. I'll stop if somebody interrupts me, so don't worry. So the first thing is I would rewrite that again. So when we have that, that means you have it as q to the power of a half. So that is divided by q to the power of 2. Okay, so now remember we want everything to be at the top. So it is q a half minus 2. And we haven't even differentiated yet. So that is by putting the -2, also don't think you actually have differentiated already. So that is just by, so all that we're now doing is to simplify it still. So what you now can do is automatically say, I want to differentiate, but the mistake that you can then make is you forget to multiply what that is at the moment with what is in front. So if there wasn't something in front, maybe you could have done it, but first simplify it out before you do the next step of integration, differentiation. Okay, because that will have an impact on what you multiply. So then we're going to multiply. So it is the 4 times the 3 over 2. Remember there's a negative. Then it is q the 3 over 2 minus 1. Okay, so that would have been 4. 2 goes into 2 once, 2 goes into 4 2 times. So, or you can have written it as minus 12 over 2, which in the end will give you minus 6. So with this one, remember it is q minus 3 over 2, and I just rewrite that as minus 2 over 2, that we at least have the same. And so that you can rewrite as q minus 5 over 2. And then again, depending on which rabbit hole we want to go through, that can be minus 6. So that can now be written as minus 6 over 5 over 2. Or that can be written as minus 6 over like that. So again, depending on what set of answers they have, that one, or that one is exactly the same. To take that minus away, but it's not. So basically any 3 of those are the same answer. So just again, depending on what the answers they are giving you. Okay, so that was the chain rule that we've explained with some of the product rules. So bit of a product rule. No, sorry. I am now going ahead. So that was the normal power rule. Sorry. So you can see from the power rule, there is simple ones in the power rule. There's a bit more difficult. What I normally nearly see it is that they normally have 3 or 4 questions on this. So between differentiation and integration, they normally have, say, 5, 6 questions. And in differentiation, it's normally one of the simpler ones that they ask. Now simple, we mean something like question 9 and not question 1. Then they normally have the chain rule, which we will get to. So between the chain rule, the product rule, and the quotient, or however you pronounce that as well, they normally have 2 questions. So they throw in the log and the exponential normally within some of these simpler ones as well. So nearly in the normal rules when can throw in the log and the exponential, and I think that is just nearly the important thing to remember from these rules are that e to the power of x stays exactly the same. So that's the one rule that, and I've written it in my set of rules as well, that that is always like that. Okay. When it's not like that, and just by simply putting a 2 there, it basically changes the rule. But what happens then is the rule is, so the rule here was that stays the same. Here what happens is that constant goes in front. And then that one stays again the same. So not like in the previous rule where we set -1 or anything like that, it stays the same. And I think that is nearly the difficulty with all of these rules. It's that luckily you can have it with you. So the paper that I've done or that I've written the rules, you can have it with you in the exam. So it's not even that you need to remember the rules, you can have it with you. And I think that's a nice thing with the online is what I would suggest, and it is, I know not everybody has the ability to be nearly in a place where you can paste stuff against the wall and things like that. But if you have that ability nearly to do that, use that opportunity. No, you were not. So there was, in some of the papers, they give you some formulas, and sometimes some of the formulas were in with the paper, but not all of them. And that's why it's nearly, for me, it's more positive that it's online, because again, for me, it's not that you need to learn a rule. I think it's more the application of that. So, and that nearly takes the stress off you as well for this exam, is you don't need to go and remember 10 or 20 rules. You basically, in a sense, just need to know how to use the application of that. So please don't go and study the lock rules. I'll have it. I'll send it tonight, the things that I've written, that it nearly makes more sense when you look at the question. You nearly need to identify what's in the question, and then you follow the rule. So that is the one, the exponential rule. Then the log rule basically says, if I have ln of x and I need to differentiate that, it becomes 1 over x. It seems like all the communication from UNISA is that doesn't matter which level we ever go to again, they want to stay online. So it will be interesting to see in the future how, if that will change again, because it does exclude a lot of people, but it makes it easier in a sense as well. But then also your lecturers need to rethink how they're going to ask some of the questions. So how the DSC paper will work is that you will be able to access it. It will be Yeah, so they've communicated that now a few times, but it will be online forever. So it's just different ways of online that I think they're still working out. So your paper was in June will still be the same in October, November, December when you write it. So it will be on the MyUnisa. You will be able to access it, download it, and that is normally 10 to 15 minutes before your original time starts. And then it is like assignment free. And you basically work through the questions and you will have an answer page that's online that you basically click to say, these are the answers. And that is how you submit it. Some of our other papers, and I know with the stats one, it's a bit different. I don't like the way the stats one is, but I think that is going to be more the way that they probably will start doing these things in the future. So with the stats one, it is you get a question, you finish it, then you go to the next question, and you can't go back to the previous one. It's everything online. What they've also introduced with the stats one is that there's not only one question. So it can be that per question there's 5 questions, so that you can't on the WhatsApp group say question 1 answer is B, because you're actually writing a different exam paper. And I think that is probably how it's going to change more into the future, is randomly you're going to get different questions in an exam paper. But for now, your paper will be downloadable as you would have had in the venue. You then select your answers and you submit it. The only difference is you submit it online. So still multiple questions and those kind of things. Okay, let's look at the next one, which is the chain rule. So what the chain rule basically say, and it's basically doing a few things. So, and let's nearly use this one as an example. So let's see, let's quickly do that. Let's just, so that we still have, okay, how many times did I now paste that? Okay, let's, okay, wait, that wasn't, so I just want to have a rule nearly with me to show you guys, when I think it's much simpler to do it that way. Okay, so basically what the chain rule says, and yes, here is the instructions of how to do it, but let's look at what it does, or what it asks you to do. So basically what it's asking you to do is you need to break that part up in 2 steps. Okay, so, and what you normally would do is whatever is in the bracket, or let's put it this way, whenever there's 2 terms or more, then we will use the chain rule. If it was 2x to the power of 5, then we don't use the chain rule. But because there's now an extra term in it, we are forced to use the chain rule. So basically what it does is to say, okay, we will take that, we will make it U or V, or we will just make it one term, and then we will work with it, and at the end we will replace that again with the original, which sounds a bit silly, but it just makes it easier to work with. So in a lot of the text, you will see normally what they do is when we work with the original, they use the y and x, and then if we start adding more, they normally use the u or the v, and it's just symbols. So it could be anything else that you also use. So I think it's just to show that it's not the normal fx is equal to y. There's a bit of change in it. Okay, so then what this rule basically tells us to do is to say, okay, we've got the one term, which is, remember we replaced it. So the one term is that. I just want to show you where the second one is that. Okay, so basically what the one does is, okay, we're going to differentiate that, and the other one says we are going to differentiate what was in a bracket. And then whatever is our answer, we will multiply it by one another. So whatever is that answer, we will multiply it with one another to get your final answer. So it's basically looking at your original. You have replaced that original with a u. So let's differentiate. So that goes in front. So it is 5u. 5 minus 1 gives you 4. Then the second part is what is in that bracket. So it's 2x plus 3. So when we differentiate that, it is 2x 1 minus 1. So that is basically 2x to the power of 0. X to the power of 0 is equal to 1. So basically what we sit with is 2. When we differentiate the constant, it automatically falls away. So basically what we are sitting with is 5u to the power of 4 times 2. So that would have been our answer, which is then 10u to the power of 4. But then we must just remember, in our original we don't have u, so we just need to replace it by that. So 10 2x plus 3 to the power of 4. Okay, so it's nearly, this is nearly what you in the will get with the chain rule. So here they explain a lot. They show you some of the other options as well, but I thought it will be better to nearly show it in an example for you. Sorry. Are you guys happy with that? I think we will show another one, which again is a bit more difficult. But do you get the principle behind it? Okay, cool. Okay, so let's look at one that is a bit more difficult. And and this is again, so this is probably more something, unfortunately, that you will see in the exam. A question 2 or question 3. Okay, so e to the power 4x plus 5. So automatically that plus 5 tells me, okay, oops, we've got a problem here. So then I would nearly say, okay, if we have it that way, much easier to work with it. So u is equal to 4x plus 5. Okay, so let's see if I can actually copy that in here as well, because it's always nice to have it as reference. Again, we don't need to remember it because you will have access to it. You just need to remember how to be able to use it. Okay, so let's quickly look at what we need to do. So the first one that we will differentiate is EU, and the second one that we will differentiate is for 4x plus 5. And then at the end, when we have differentiated both of them, we will multiply them. Sounds very easy if you explain it that way. So let's see how easy this one is actually. So when we differentiate e to the power of u, it is e to the power of u. So remember, when we add e to the power of x, it actually stays e to the power of x. So just remember that is universal for whatever nearly sign is at the top. So that one was actually quite easy. If you look at 4x plus 5, nearly the same as the previous one. The x will be 1 minus 1, which makes it x to the power of 0, which makes it 1, so 4 times 1. So if we differentiate that, it would be equal to 4. And then we have, if you multiply the two with one another, 4e to the power of u. Then we just need to remember, we need to replace u. So we have 4e to the power of 4x plus 5. So it nearly feels to me what we could have done here is nearly took that, put that in front, and kept the rest as is, and you would have gotten the same answer. But I think we wanted to go through the process just to show that. Okay, questions on that question 2 or example 2. So again, if you nearly have this formula in front of you, it's much easier to nearly solve the answer. But I think the important thing also is, and that's the one thing that's nearly the most difficult normally, is to nearly recognize which formula you need to use when. um, so nearly saying, and let's write it where, let's say something like that. Patricia, do you mean something like that? That's just now terrible. Okay, so say it is something like that. You follow the exactly the same process. So the only thing that will be different now, and let's do just maybe show it there. So you will still say u, but when u is equal to that 1 over 4x plus 5, and then you work with that. So then you can probably say, so in this part of a differentiation, it will then change, but that part not. So the only place where it will then change is in this part, because that then is a bit different. But then you basically can work with 1 over 4x plus 5, which you can rewrite as to the power of -1, and then with that and the question is if there is a way of doing it. So again, so the only thing that I can see there, it feels like nearly, see what they won't do is in this way do it. I'll show you another place where they will do it, because now you have within this a difficult function that you guys haven't done yet, because what do you do now with a negative? So within the e function they won't do it, but I'll show you now at another place, because that would still be the same. So it's only there that the differentiation part will be different. Yes, so it is, you will need to use 2 rules within one question, but it's, and I don't want to say very seldom, but it's very seldom, and I'm going to use it, that they do the quotient rule, because that's where you divide, or have what they can have a product rule and the chain rule in one, but very seldom they put the quotient rule with something else, because that makes it extremely difficult. So they can have it as 2 rules within one, but it's nearly, they won't make it that difficult. So you don't need to nearly stress too much that they, and they won't put it in the 2 rules within the ln or the exponential one, because that just makes it completely nearly, not, I don't want to say unworkable, but very difficult. So they won't go to that extreme. So you don't need to worry about that. So just to put you at ease with that. Because you can already see with this is nearly already a next level. So what they can do is, and let's look at the ln one, is nearly, because this is a bit where it is 1 over something. but they won't, it's like they won't do this. They won't do something like, because that is just, it's just not on. So you don't need to worry about that. Okay, so let's look at this one. So we've now learned a bit of what the Lin rule is, or the lock rule. Now we look at this function. And because that is, again, two terms, I automatically go to, okay, this must be then the rule that, and which rule do I use? So I automatically go to the chain rule. Then I, again, tell myself, okay, I will replace that by u. So the first thing is, here we only have ln u, and let's just write it a bit better. So ln u will be the first one that we need to differentiate, and the other one that we need to differentiate will be 5x minus 1. So ln of u, ln of x, ln of whatever, it's all the same. So it is 1 over u if you differentiate. With all the others, what we've seen, if we differentiate that, the x will basically become 1 minus 1. So there we will sit with 5. And now it is, let's just multiply the two. So basically, it is 5 over u. Then you replace the u again, because that is what we did. And it becomes 5 over 5x minus 1. So with these two, it's nearly, it seems difficult, but it's, if you use, and in both of them actually you use previous rules as well. So you need to know what the Lin rule is, you need to know what the exponential rule is, so that you can do it. So in a sense, the chain rule is automatically, with that first question, that was just straightforward, because that was normal differentiation with a bit of a chain rule. Here you needed to know what the exponential rule does and how you use it, and the Lin rule, know what it is, or the lock rule, and know how to use it. Okay, so I think we can not do this one. It's very similar to the other one. I'm conscious of time, so I nearly want to go into the product rule, and then next week we can basically do the rest of chapter 5 and chapter 6. This is nearly the same how it panned out the previous semester as well. So it's not that it's taking longer. We did nearly the same in the previous semester. We didn't finish the first differentiation part, but then with chapter 6 that are more basically application, it was easy to catch up, and then the week after that we will do integration. Okay, any questions up until this point? Okay, cool. So I just always like to have a rule with me so that we can really explain. Nice, just go out before you move it. Okay, cool. Okay, so And yeah, Colleen, I can't stress it more than that even. The more papers, the more things, because as you would nearly see, I've seen out of the assignments as well, there is just, and your assignment 3 was one of the previous exam papers. So I've now realized when I saw that semester 1, that assignment 3 was also one of the previous exam papers in 2018. So the things are being recycled, and it is nearly just to practice, because and yeah, there is sometimes 1 or 2 questions in the exam that's new, but otherwise it is very similar things that are being asked the whole time. Practice, practice, practice. That is basically how we need to do this. Okay, so let's look at this one, and nearly also want to show. So the previous set of things was you had one function that you needed to break up. Here you're sitting with 2 functions. So that is one, and that is another one. So it's not that you can just replace and say u. Now you have 2. So it is, the one will be u, and the other one will be v. So, and I just always nearly how it works is the first one we make u, the second one makes v, and that is just nearly by principle how we like to do it. Again, you can call it whatever you want to. In the end, your answer will not have a u or a v in it. So if you want to call it A and you want to call it B just to make it easier for yourself, you can do that as well. So basically what this rule nearly wants you to do, and I think that again is the important thing, is again it's a very simple process, but it is step by step you need to do it. So what this rule tells us to do is to say, okay, let's take the first one. We differentiate u. So remember, we differentiate u and we multiply it by the second one. So we differentiate u. So ex differentiated is ex. And we multiply it by the second one. Then we differentiate the second one. So if we differentiate that one, it is the 2 goes in front. 2 minus 1 becomes 1. The 5, because it's a constant, disappears. So basically we differentiate and we multiply by the first one. Okay, so the original was we differentiate the first one, multiply by the second one, then we differentiate the second one, multiply by the first one, and that is your answer. So let's see if I multiply that out, because it seems like that is what they did. No, they just, so what they did was to take out a few of the things. So let's just write that over. And let's just see what they did. They multiply it by 2x. So because that was in both, all that they just did was to simplify that. So that's x squared plus 5 plus the 2x. Okay, so that is just all that we do. So again, when you look at the formula, it's overwhelming, but basically how I remember it is, and let me, because I think that is nearly the easiest. So how I always remember it is differentiate that one, multiply by that, multiply that with a differentiation of that one, and then you add that and that. So it's nearly, when I look at a question like that, it is first term differentiate times the second term plus the second term you differentiate times the first term. Okay, does that nearly make sense, and does the explanation help a bit? Okay, you guys are very quiet now, so or you're very shocked or it is sinking in a bit. Okay. Okay, so I nearly want to stop here, but let me, so let's, while it went over the head, let's quickly, I'll explain this one as well, and then it's practice time. And I think don't go and do then too much, because it is overload, and I think that is nearly, I don't want to do more because it is overload. So again, make the first one U, make the second one V. So how I would look at it is differentiate, and I'm going to use now that. So differentiate the first one, multiply by the second one, and then add that you take the second one and you multiply it by the differentiation, and you basically add those two together then. So if I differentiated that, and I'm now nearly gonna differentiate it a bit out of my head, so x to the power of 2 is 2x. 2x, if I differentiate that, will be 2. Okay, and then I just write the v as is because nothing changed there. Then I take the second one, so the second part, so the u I take as is, and I need to multiply that by the differentiation of v. And the differentiation of v is the 2 will fall away, 3x is actually then 3x1 minus 1, so it basically becomes 3. So with this one, there's still more work to do, because now you need to multiply those two terms, you need to multiply that to get to an answer, as you will see here. But that is nearly what I wanted to show, that in principle, it's an easy step nearly, but it's nearly, like you also said, practice, practice, practice. Yeah. Okay, that's a lot of information for Friday afternoon. We still have time to the exam as well. Next week, we will just continue and nearly finish all the differentiation stuff. And then the week after, we will focus on on integration. Okay, ask a few questions, guys. For the guys that have joined during the session and are not part of the WhatsApp group, send me a WhatsApp on 0837908387. I will add you. I see I did receive one or two, so I will add you in a few minutes time. Okay. Questions? Overload, headaches. Okay, cool. Okay, so let that sink in, and we can have the discussion later on WhatsApp as well, and share and things like that. Okay, have a good Friday evening and a great weekend, and we'll chat again next week. Okay, cheers, guys.
Thank you so much, Jean.